Hello everybody, welcome to the Java example section. In this section, I'm going to simulate a solar toy car. First, I would create a ToyCar class, and then I would create a solar panel interface. That means I can combine the ToyCar class and the solar panel interface to create my solar toy car class. Okay, and in my solar toy car implementation, the instance coming from this class can have its own charging approach, which is different from that of the conventional toy car. And a solar toy car instance can also work with the solar energy directly, which is having a different approach of using energy than the way for the toy car class. Now let us see the implementation. I would start with the toy car class first. For a toy car, I would have two instance variables. A toy car would have a battery level, it also has a variable which is a final variable representing the full battery level of a toy car object. This final keyword means that I'm not able to change this value any longer after setting up it with a final keyword. And we can see that both instance variables are having the protected access modifier. It means that I'm going to set up a solar toy car class which can access these two variables directly without using the getter methods provided by the toy car class. It would simply ease my process of creating the solar toy car class. Okay. Now I create a constructor of the conventional toy car. When I set up a toy car object, its battery level would be simply equal to 1000 units, which is the case when the battery is fully charged. And now I give some methods for a particular toy car object. I can tell it to move forward by a certain distance. I can tell a toy car to go forward for some meters, indicated by the formal parameter called distance. Here, the battery level would also be reduced by the same amount as the distance in meters. What does it mean by that? It simply means that 1 unit of distance is equal to the consumption of 1 battery level. Okay. In addition to the movement, a toy car is also able to turn. I can turn left or right by some angle, and direction here is simply data type indicated by the enum keyword, which is shown here. When I want to set up two constants, by using the enum data type, I can do something like this. I have two constants, one is left and one is right. Usually we would use all capital letters to declare the contents in the enum data type. Let me save it. That means I can turn left or turn right. The direction of the turn can be shown in the printing statement. I can also explain the degrees of the turn. When I do the turning action, the battery level would also be decreased. The battery level would be dropped by the same value as the angle. That means 1 unit of rotation or turning would be equal to 1 battery level. Okay, I can also create some getter methods for the instance variable called battery level. This getter method is for the outside world to understand the battery level of a certain ToyCar object. Of course, a ToyCar needs to recharge, so I set up a method called charge battery. A conventional ToyCar would need to be charged up from a wall socket. After charging, the battery level would return to the full battery level, which is simply 1000 units. Okay, so this completes the ToyCar class. Let me save it. And now I can go to the solar panel, which is simply an interface. I will have 2 solar panels for each solar panel component. Okay. The solar panel needs to be recharged, so the charge battery method should be a bit different from the one in the typical ToyCar class. Okay. Solar ToyCar is also able to move with the solar energy coming from the solar panel directly. So I have to set up a method pertaining to this situation. That means I'm not going to use the power coming from the battery in the conventional ToyCar. A solar ToyCar is also able to turn by consuming the solar energy stored in the solar panel. So this completes the interface of the solar panel. Okay. So these methods will be implemented in the solar ToyCar class, which combines the ToyCar class together with the solar panel interface. Okay, let me go to the solar ToyCar class, which extends ToyCar and implements solar panel. And we have to remember that the extends keyword should come before the implements keyword. Now we see that we have a charge battery method in the ToyCar class, but also we have the charge battery method in a solar panel. So what does it mean by that? I can do the method overriding for the solar ToyCar class. I'm going to override the charge battery method coming from the ToyCar class. So the solar ToyCar is going to charge up by using the solar panels. And I can show the number of panels contained in the particular solar ToyCar by calling the static variable in the solar panel interface. Okay. After charging by the solar panel, the battery level would become the full battery level, which is simply equal to 1000 units. Because this variable is a protected variable, the subclass coming from the superclass is also able to access the protected variables directly. Now I set up the two methods coming from the solar panel interface. The solar ToyCar can move without using the battery power. It simply uses the power coming from the solar panel directly. In this case, the battery level would not be lost, so I don't need to set up the battery level after the movement. I can do similar things to the turn with solar energy method. Okay, this completes the solar ToyCar class, which has a lot of properties coming from the ToyCar class and the solar panel interface. Let me save it. Okay, there should be no problem with the solar ToyCar class. For now, I can go back to the driver program. to see how I can call the solar toy car objects. Now I'm going to set up a solar toy car object. Okay. The solar toy car class has no constructor being set up explicitly. That means I'm going to use the default constructor of my solar toy car class. Okay, I can tell my car object to give me the battery level. I can also tell the solar toy car to turn right by 45 degrees. So the turn method must be simply inherited from the toy car class, which is shown here. Okay. When I turn the solar toy car with the turn method, I'm going to use up the battery, so the battery level would be dropped. And we can see that the illum data type is employed here by using the direction dot right value coming from the direction illum data type. Okay. After such turning motion, I can see the battery level later. I can also tell a solar toy car to move forward by 30 meters. When I use the forward method, it simply comes from the toy car class, which would use up the energy coming from the battery. So in this case, I can check the battery level after the movement action. Okay, I can also tell my car to turn with solar energy by 20 degrees. After that, I'm able to check the battery level, because the method shown here would not consume the energy coming from the battery. The battery value should be unchanged. You can see the result later. I can also tell my car to move with solar energy for 100 meters. And of course, I can show the battery level after this movement with solar energy. I can also tell my car to charge battery. Since the solar toy car has already overridden the method coming from the superclass, we would be able to see that the solar toy car is going to charge the battery a bit differently. can show the battery level after the charging action. So let me save it and try to run it. Yes, a lot of output coming out. When I set up the constructor, the battery level would be initially 1000 units. After turning right by 45 degrees, the battery would be dropped by 45 units. So it remains 955 units. And after going forward by 30 meters, the battery will be further dropped by 30 units. So it becomes 925 units. And when I turn the solar toy car by 20 degrees without using the battery power, the battery power would remain unchanged. Same for the case when I move with solar energy. The energy stored in the battery will not be lost. So when I charge the battery for my solar toy car, I would charge it with my 2 solar panels, and after the charging, it would return to 1000 immediately. So this completes my solar toy car simulation. My code is intuitive and straightforward, but it may not be the most efficient approach to the problem. If you can suggest any idea to improve my code, please do so on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.